now it's the time of our colleagues. I'm really pleased to invite our colleague, Dr. Enrique Moliner, which is a senior sustainability technologist at LOMARTOV, and he's going to show impressive figures on the environmental performance of the new heat exchanger with respect to the state-of-the-art solution. So, Quique, the floor is yours.
Thank you, Isaac. So, well, my speech today is on the benefits and opportunities of the Ecodesign for e-vehicle components, and I will do it through an example, through a clear example of successful implementation of Ecodesign, which is the product developed in our i-HeCoBatt project. Sorry. So what we have here is a very brief summary of the main achievements in our project. We have a new flexible cooling system based on the MIBA technology and the flex cooler, which has been demonstrated to be fully functional and which also incorporates some additional features like sensors and heaters by means of printing electronics technology. And this new product, when compared to the conventional cooling system, allow a carbon footprint reduction by over 64%. And according to our cost estimates, it can also bring economic savings in terms of production costs, significant economic savings. And in addition, what we have is a lighter system. And also, my colleagues already talked about the improvements in the thermal management of the battery pack, which results in extension of the service life of the battery pack and also an increase of the powertrain efficiency, which means less electricity consumption during the operation of the vehicle. So we have here an example of Ecodesign providing environmental benefits, but also economic benefits both for the producer and the customer, the user of the e-vehicle. So the first idea I would like to highlight is that the development of greener products does not necessarily involve more expensive product or higher costs. And these kind of achievements can be done through Ecodesign. So I would like to give answer to these kind of questions today. What is Ecodesign? Why applying Ecodesign? How to apply it? And then I will briefly explain this through our success case of Ecodesign in the project. And finally, as a conclusion, I will highlight the benefits and opportunities in Ecodesign for the companies. So let's give an answer to this first question. So Ecodesign consists in integrating the environmental aspects in the process of product design and development. But it is not just about environment, but what we do with the Ecodesign is to give to these environmental aspects the same level of importance as receive other specifications that are traditionally considered in this design process, like the product quality or functionality, the safety, the legislative requirements, the costs, and so on. And the objective, therefore, is to complete with all these specifications, all these technical specifications, and at the same time minimizing the environmental impacts of the product through the whole life cycle. So Ecodesign follows this life cycle thinking approach. It considers all the life cycle stages of the product, from the cradle to the gate, from the extraction and processing of the raw materials used in the product, the production, the distribution and the use, and finally the end of life. So we should consider all these aspects related to all the life cycle stages to be sure that we are developing a product with improved environmental performance. So this is a very brief introduction to the Ecodesign, and now we are explaining why it is so important to follow this, to apply this eco-design and to follow this life cycle thinking approach. And well, let's say that traditionally the focus or the efforts for environmental improvement of the products have been put on very specific stages, mainly on the production stage, because it is where the manufacturers feel more comfortable or where they feel that have more control or full control. But the problem is that there are other life cycle stages that can also have really important environmental impacts, like the materials used for the product, the extraction of these materials, the end of life of the product, or for instance the use stage, which is especially critical in motor vehicles. Either they are combustion or electric vehicles, because at the end we have a vehicle consuming fuels or electricity during a lot of years, maybe 10, 15, or even 20 years, so the impacts in this stage are huge. So it is very important to change this paradigm and to widening the scope of the environmental improvement actions to other life cycle stages, if possible to cover life cycle stages, because it is the way in which we will be able to move towards sustainable consumption and production. And this is something that we should be able to do from the very early stage of product development, from the design stage, because once the product is fully designed and it is launched for mass production and it enters into the market, it is very difficult to apply significant changes that could result in important environmental savings. So this is why it is important eco-design and following this life cycle approach and considering the whole life cycle of the products. Well, and now let's explain a bit more about the eco-design, how to apply eco-design. Well, I'm not explaining in 5 minutes how to apply eco-design, but I would like to say that it is a systematic procedure, so we cannot apply eco-design in a randomly manner, but it is something that must be done in a systematic way. You have here the whole eco-design procedure, which involves several steps, from the creation of a multidisciplinary team up to obtain a product prototype, a eco-design product prototype. But I would like to stress the importance of some of these steps. First, we have 2 steps where we are conducting an environmental assessment of the product. One will be the environmental assessment of the current product, of an existing product, because the eco-design usually involves the redesign of an existing product that wants to be improved from an environmental perspective. And then we will apply again the environmental assessment once we have proposed some eco-design measures to improve the product. So the idea is to know the environmental impact before and after the application of these eco-design measures to be sure that we are actually achieving environmental benefits. And for this purpose, there are several tools that can be used for the environmental impact assessment, but the most widely used and the most recognized tool is the life cycle assessment. So this methodology is first applied to calculate the impacts of the current product across the different life cycle stages, and this is really useful because in this way we are able to identify the environmental hotspots of the product. I mean, the life cycle stages or the processes or the aspects that are more critical in environmental terms, the aspects that has the greatest impacts. So in a further step, this information will allow us to propose eco-design measures to address these specific aspects and reduce their impacts. And then, as I told you before, we need to also apply the LCA once we have developed a eco-design concept to be sure that we are achieving actual environmental benefits and to avoid what is known as problem shifting, which means that we often apply some environmental improvement actions to reduce the environmental impacts of the product, but what we are doing is to shift the impacts from one stages to others, or from one region to other, or from one process to others. While at the end, what we achieve is even to increase the overall impact of the product. So we are achieving just the contrary of what was expected. And this is what we can avoid with the LCA. And well, and another very important step in the eco-design process is the proposal of eco-design strategies and actions. And you have here a summary, an overview of all the type of strategies and actions that could be applied. So you have there actions linked to every life cycle stage, to the materials, to the production, to the distribution, to the end of life, to the use. And there is no one single solution that works for all products, but we must choose specific actions depending on our product, depending on the driving factors that motivate our co-design project, and well, depending on the feasibility of each solution in technical, economic, regulatory terms, and so on. And all these aspects are analyzed in detail in a co-design project. So I would like to insist that this is something that it is not applied randomly, but it is a systematic procedure supported by scientific sound methodologies like the LCA. And well, I'm now explaining a bit more about the eco-design, putting as an example our heat exchanger developed in the i-HeCoBatt project. So this is the LCA of the current cooling system. And what you can find here is how the different components of the current cooling system contribute to different environmental impact categories. So you can find in the blue bars that it is quite clear that there are two components, which are the environmental hotspots, which show most of the contribution to all the environmental impact categories, which are the aluminum cooling system and also the thermal gap filler made of a silicon compound. So in the project or in the new product, it was clear that it is necessary to attack these components to improve the performance, environmental performance of the product. So we have here all the set of eco-design strategies and actions, and these are the ones that, and these are the ones that we're applying in the current product. So the aluminum cooling system was replaced by a plastic-based cooling system, a flexible plastic-based cooling system, which these plastics has a lower energy content than the aluminum, and it was also possible to eliminate the thermal gap filler. So we have improvements in terms of materials. It was also possible in this way to achieve a very significant weight reduction in the product, around 90%. So this also translates into benefits for the distribution, for the product distribution. And then there was another strategy, which was the integration of function by means of the printed electronics. So the flexible flex cooler was printed with these sensors and actuators on the heaters to improve the thermal management of the battery pack. And this also represents an alternative manufacturing process to the conventional electronics used in the battery pack for the thermal management. So I would say that this printed electronics technology also delivers many opportunities for production optimization, as you can shorten the process or make it simpler than with the conventional electronic components. And well, and I also explained before that there are other benefits with this system related to the durability of the battery pack or to the reduction of the electricity consumption during the use, thanks to the lightweighting of the vehicle with this lighter system, and thanks also to the improvement in the powertrain efficiency because of the thermal management system and the lightweight. So if we compare in this spider web graph, you have a comparison between the current cooling system and the new one developed in the in the project, and it is a qualitative comparison where we can find that for most of the strategies and life cycle stages we have achieved improvements. I would say that only in the end of life we may have some worse scenario because we have the initial product which has a very big amount of aluminum, which is highly recyclable, while the plastics of the new system, maybe today with the infrastructures and capabilities for end-of-life vehicle recycling, will harder be recycled by maybe in the future. Anyway, this is only a qualitative comparison, but to be sure that we are actually achieving environmental savings, you know we need to apply the LCA. And you have here the comparative results of the LCA of the existing system and the new one. So we have in the dark blue bars the reference, and then in the green bar you have the new cooling system, and you can find that we achieved very important environmental savings, even including the printed electronics. The electronic components are not included in the existing product, but even including them in the new one, in the assessment, you can find that we still have a lot of benefits in environmental terms. And we also make an estimate of the benefits that can be achieved during the use stage thanks to this new system. This is the reduction of the carbon footprint of the greenhouse gas emissions thanks to increased powertrain efficiency with the new system. So we investigated what will happen with this for different ranges of powertrain efficiency, and you can find, if we compare the benefits against the impact of producing this system, you can find that we can reach up to 10 times savings compared to the impact of producing this new system. So these are very interesting results. And finally, as a conclusion, I would like to talk about the benefits and opportunities for companies. It is clear that through the eco-design, we can improve the environmental quality of the product, but not only the environmental quality, but the technical quality. The eco-design involves a detailed analysis of the current product, so it is possible to find technical hotspots as well and apply improvements from a technical point of view. It is also possible to achieve cost savings, as demonstrated with this new product in the project. It is also a way to promote eco-innovation in the companies, which is always good. And it can be a tool to anticipate future regulatory changes. And finally, Ecodesign is also a tool for green marketing. There are many tools that the companies can use to communicate their environmental achievements and the implementation of Ecodesign, like eco-labels, certifications, and so on. And at the end, it's also a way to achieve new markets and new customers more environmentally aware. So all of this translate into an improvement in competitiveness. So that's all. Thank you for your attention. And if you have questions, I will be delighted to reply.